Here's an explanation of the y-intercept. But first we have to look at the format that the book likes to use for an absolute value function. And here it is. We have y equals a, and then the absolute value of some stuff. You see x in that stuff, so x might be multiplied by something. There might be an addition to it. So there's a bx plus c stuff in the absolute value plus d. So if we see this format, we immediately recognize a couple of things. One is that if bx plus c equals 0, and I'll write that down, if, put that in the color pink here, bx plus c, if that equals 0, then the absolute value of 0 is 0, a times 0 is 0, and we're left with y equals plus d, or y equals d. Then y equals d. Now d is a single number, it's a constant. And if we were going to graph any sort of absolute value function, we'll take that one there, we know it's going to look like a v, it's going to have a vertex. A v doesn't stand for vertex or anything like that, it looks like a v just because it does. So the vertex point here is a single value for y, and that value is d. Every other y value that is actually part of the function has two values, like this one and this one. So if y equals whatever that is, there's two x coordinates that match it because it's a v. But where there's a single coordinate for y, that must be the vertex. So if we have this formula, if we can set this pink stuff here to 0, then we can figure out what d is. I'll say that again. If this stuff equals 0, y equals d. In other words, where bx plus c equals 0, y equals d, and this is the y value of the vertex. Now there are two things there. One is that y value of the vertex can be recognized if bx plus c equals 0. But what about the x value of the vertex? Well, the x value of the vertex is actually hidden here. All we have to do is isolate c. And we can do that this way. bx plus c equals 0. Let's just subtract c from both sides, and we get bx equals negative c. And then we'll divide both sides by b, and we'll get x equals negative c over b. And once again, we're talking about the vertex, and therefore this is the x value of the vertex. So the vertex, by virtue of our little calculations here, the vertex equals the following coordinate, negative c over b, comma d. As long as the equation can be written like this, we can recognize the vertex with this formula.